I am so excited. Not only do we get to do calculus today, but these are the last pages in our daily lessons. What? From here on out, it's just putting all this together, practicing, trying to figure out just how calculus works together and how you can learn it better. So let's get right into it. So this is volumes of solids with known cross sections. So if you were in my classroom, you would actually see a whole lot of what I think is really cool art on my walls, which is actually just a lot of these different volumes with known cross sections. So what I mean by that is if you take the distance between, let's say, this function f of x and this function g of x, and I want to make a square, that distance, because squares have the same side lengths on all four sides, you'd have to go up 90 degrees from whatever that distance is. And then you would have to go the same thing over here and over here, 90 degrees, but that same distance, and you form a square. But let's say down here, where these functions are pretty close together, you would form a smaller square. So some of the squares in the center are going to be bigger, the ones on the side are going to be smaller. And if you put an infinite number of those squares together, you get the volume of this really cool looking region. It's going to have a flat bottom between these two functions, like it's sitting on a piece of paper, but it's going to form a really cool region out of which with these known cross sections. Cross sections are just if you took a solid and you sliced it, you could see what shape it would make. In this case, we've got squares. We've got other ones that are isosceles right triangles. There's going to be equilateral triangles and semicircles. That's what we're going to do. So let's just think, what do I actually want to do to find volume? Well, in the last section we did, when we were rotating around an axis, we could take an area of a circle. So we took pi r squared, or if there was a hole in the center, we took pi r squared minus pi r squared, the outer minus the axis squared. And we did, we found the area of one circle. And then if you integrate it, so if you're integrating pi r squared, you get back to volume. Same idea here. We're going to integrate one of the areas of each of these cross sections, whatever they are. So let's think about this. If I want to find the area, I need to know the side lengths, because the area of a square would be base times height, or length times width, however you want to say this. The distance from here to here, big triangle, big rectangle, square, little square, whatever it is, squares. I'm going to say the distance from here to here would be f of x minus g of x. Just like if you were at position 4 and I was at position 2, we were 2 away from each other. Same idea here. So to find one of these, I say f of x minus g of x. This side is also going to be f of x minus g of x. So if I want to find the area of just one square, not even worried about volume yet, but just the area, I would say that this would be f of x minus g of x, so my base, times my height, or if I wanted to simplify that, anything times itself we can write as f of x minus g of x, and then squared. In order to turn this area into volume, I have to integrate. And I'm going to say between a and b, wherever a and b are, this would be the x value and the x value, a and b. So between a and b, volume, I don't need a pi outside this one because I'm just taking the area of squares and integrating that. So I'd say f of x minus g of x squared, because I'm adding up all of the infinite number of areas of each one of these squares. Okay, so we've got this one. Now let's go to the next one and think, same idea. Now I've got cross sections that are isosceles right triangles. So anywhere the distance from here to here, so of this base, will still be f of x minus g of x. Think about an isosceles right triangle, right? Isosceles means that the legs are the same. So this would be f of x minus g of x. How do you find the area of any triangle? Oh, area is 1/2 base times height. Substitute in what we know. Area is 1/2. My base in this one is f of x minus g of x. my height is f of x minus g of x. Is there an easier way to write this? Sure there is. Area could be 1/2 f of x minus g of x squared. What? That kind of looks like that one, except this one has 1/2. Yeah, because even if I say, you know what, I'm going to integrate this and do the volume, 1/2 is just a coefficient, so I can bring that out in front. And I'm going to integrate from a to b this area, which is just f of x minus g of x. And actually, if you would think about a shape like this, if you would cut it all in half, you're actually cutting the volume in half as well, not just each of these areas. So, for area of an isosceles right triangle, it's actually the same thing. It's just 1/2 f of x minus g of x squared. And then so volume is going to be 1/2, the integral from a to b, f of x minus g of x squared. Let's do more. I will let you know this one is the most complicated one because we've got equilateral triangles, but I also tell you that there is something really easy that you can memorize at the end. So just be prepared. So this one, if I'm doing an equilateral triangle, can you guess what this base is going to be? F of x minus g of x. Yeah, it's just the distance between the function values. So f of x minus g of x. This would be the base. But the area of a triangle is 1/2 base times height. So I could say 1/2, my base I know, it's f of x minus g of x. My height gives me a little trouble in this one. So I know I've got to multiply by some height. But the thing is right now, I know this slant height is f of x minus g of x. This is too, but it would be like going to the doctors and then be like, how tall are you? And I'd be like, measure me. You have to stand up straight. So here's where we have to know some things about equilateral triangles. So to find this height, I actually already started writing this over here. Equilateral triangles, I know I'm going to go back to degrees just for a second because sometimes I think that's easier to think about. If you have a 60, 60, 60, right? But I cut this one in half. So now I have a 60, 30, and I made a straight line, a perpendicular bisector right here. So, flashbacks of geometry, right? This is 90 degrees. So I have a 30, 60, 90 triangle. Remember, these are special triangles where we have this relationship. We have x is one of the legs. It's going to be the shortest leg. Square root of 3 times x is the longer leg. 2 times x is the height. I'm saying this because let's think about what x is in this case. It'll only be from here to here. Yeah, so x in this case would be, x would have to equal 1/2 f of x minus g of x. Which means if I want to know what my height is, that would be square root of 3. Height would be square root of 3 times whatever my value of x is, which in this case is this 1/2 f of x minus g of x. So if I go down here, my height, I'm going to write, this would be square root of 3 square root of 3 over 2 f of x minus g of x. Okay, make sure you're okay with this for right now. You will not have to do this every time. I told you there'd be an easy way at the end. I was not lying to you. But do you see how this height is square root of 3 times whatever the base is? This base is only half of f of x minus g of x. So I have square root of 3 times 1/2 f of x minus g of x. If I simplify this, area is really just square root of 3 over 2 times 1/2 would be square root of 3 over 4 times the quantity f of x minus g of x. Did you guess it yet? Squared. Hey, it looks like the other ones, except when I do volume, instead of just doing the integral from a to b and then doing f of x minus g of x squared like I did for the square, or 1/2 like I did for the equilateral right triangle, or not equilateral, I did the isosceles right triangle, that was the 1/2. Now I'm going to have square root of 3/4. And I'm going to get down here, but actually all of these are going to be some constant times the integral from a to b f of x minus g of x squared dx. So for any of these shapes, that's what it's going to be. And the constant is going to change depending on what shape. So this is something that you can memorize so you don't have to go through these steps every time. Just know that a square is just f of x minus g of x squared. Isosceles right triangle we said was 1/2 times f of x minus g of x squared. And then now we've got equilateral triangle multiplied by square root of 3/4. Let's do one more. You're like, this one doesn't look like it's going to be something like that. Let's try. This is a semicircle. So it says cross sections that are semicircle. So we need to take the area of a semicircle. Let's think. How do you find the area of a circle? Pi r squared. But this is only half a circle, so I've got 1/2 pi r squared. What is the distance from here to here? Have you guessed it yet? Yeah, it's f of x minus g of x. So how does that play into our formula? Area is equal to 1/2 pi r squared. Remember that radius is halfway across the circle. So if I'm talking about this, radius would be, from the center of the circle to the edge, or I could say from here to here. So the radius would have to be 1/2 f of x minus g of x. Okay, this is I would say the trickiest part of all of this is simplifying. I've got 1/2 pi. When you take 1/2 f of x minus g of x and this whole quantity squared, you have to square that 1/2. 1/2 times, or squared, would be the same as 1/2 times 1/2, also known as 1/4. Now I have this quantity, f of x minus g of x squared. Let's simplify this a little bit. This would be the same thing as pi over 8. What do you do then if this is the area of just one of these semicircles? To find the volume, you integrate from a to b, whatever the intersection points are. So even this last one that didn't really look like it was going to have a coefficient, still does. It's some constant, or I should say some coefficient. Yeah, constant, coefficient. I'll even put coefficient, because constants usually like plus c. So some coefficient times this integral from a to b, f of x minus g of x squared. Every single one of these. And so now we get to use it. Last page. What? Is anyone else cheering? What? I feel like I should have confetti, but then I'd have to clean it up, so I don't really want that. Okay, so it says region R is bounded by sine of pi x and x cubed minus 4x. This first one, it says actually for all of these, find the volume of the solids formed by cross sections of the shapes indicated below. So this is how you know to do this type of problem. When you see find the volume of solids formed by cross sections. The cross sections are perpendicular to the x-axis. This just means everything's normal. Every once in a while you will get ones that are in terms of y, where you can go the other way, but if these are perpendicular to the x-axis, this is like normal stuff is going on, where I can use f of x and I can use g of x, and I don't have to put anything in terms of y. Okay, so in every one of these, you're going to be thinking, well, volume, I have to integrate the area. So cross sections that are equilateral triangles. Remember this. Oh, this was a tough one to start out with. But we do know that we're going to go and we're going to integrate from here to here, which in this case is 0 to 2. So like, I'm not sure about that. And you want to make sure that they intersect at 0 and at 2. You could do sine of pi x x cubed minus 4x. And then if you want to say at window, I'm going to go from 0 to Actually, I'm going to do like negative 0.1 to 2.1 to go a little bit past that point. Negative 3 to 1. So I'm going to do negative 3.1 to 1.1. This is the one, we actually did a graph like this before, because remember I talked about it looking like a bird. Told a story about going to a fair when I was really little. It was like a thing at my school, but whatever. If I push trace, you see how this top function is sine of pi x? If I push trace again and I push down, I can see this other function is the x cubed minus 4x. So this one I know is sine of pi x. This one I know is x cubed minus 4x. Okay, so I've got my top function, the bottom function. I'm going from 0 to 2 if you wanted to make sure. And you, actually, I'll go here. Do you see how at 0? Hey, look, they're the same. At 2, hey, look, they're the same. So I don't even have to do the intersection points. I know I'm good. All of these are going to be from 0 to 2. Equilateral triangles. Remember, what was the equilateral triangle again? What was the coefficient? Square root of 3 over 4. F of x, so the top function, sine of pi x, minus my bottom function, don't forget parentheses, x cubed, minus 4x, squared, f of x minus g of x squared. If you wouldn't have labeled this as f of x and g of x and then just write f of x minus g of x every time you can. I'll find this out in a second, but I'm going to actually go through the other ones while I want you to, and then see what you can get. E and F are a little bit tricky, but I think you can still get them, but you have to think through the process. It's not just like memorization. You have to think through, what would that actually mean? Okay, you go. Try the other ones. What do you think? Just setting it up. We're not even finding this number in my calculator yet. Okay, so a semicircle would be pi over 8. Isosceles right triangles. 1/2. Squares just have 1, so this would be 1, or you could say 0 to 2. Oh, I almost wrote f of x minus g of x. Okay, check yours with mine. Did you get that if I just have a cross section that are squares, this would be 0 to 2. And then I do f of x minus g of x squared. Don't forget about the parentheses. The only thing that's different is the coefficient, and all the rest of these ones, they're in A through D. So here, the equilateral triangles, make sure you got square root of 3 over 4. Cross sections, pi over 8. Isosceles right triangles, 1/2. If you need to go make note cards for yourself or something right now to get these in your head, do that. This would be a good time. Okay, so instead of trying to solve this over and over and over again, like in putting these in my calculator, what I'm going to do is I'm going to do a math 9, and I'm just going to do this once and make sure I don't mess up. This would be 0 to 2, sine of pi x, make sure your calculator's in radians, x cubed minus 4x, oops, that would stink, minus 4x. When you square this, make sure that you've got squared outside of the entire thing. Do you see how this square is outside the parenthesis? It started with a parenthesis in here. Actually, I might even add one more parenthesis. There we go. Be really careful with your parentheses here. I feel like I have too many parentheses now. No, I'm good. Hey, did you get the same thing as me? I can put this as my final answer. That's fine, this one. But make sure you use more than 3 places after the decimal to do all the other ones. So instead of just doing this over and over again, it's already in my calculator. I'm just going to do times pi over 8. Hey, I got 3.918 for this one. I want them at 9.97 again. Times square root of 3 divided by 4. 4.320. And this one was the same as 1/2, so I'm going to go back up to here, times 1/2, 4.989. Ta-da! Okay, the last two. If you haven't tried these yet, now's a great time. So this one are cross sections that are rectangles. Let's think about this. Whose height is twice the length of the base. Cross sections are rectangles whose height is 1/3. Okay, so if before it was the same, if it was base times height and f of x minus g of x, and then it was f of x minus g of x for the height. Here, if the height is just twice, it's just going to be f of x minus g of x. This is for area, by the way. This would be the base. The height would be twice that. That's it. So when you're integrating this, the only thing different, I'm still going from 0 to 2. I'm still doing f of x minus g of x squared. The only difference is you multiply this by 2. So what do you think this one is? Yeah, if the height is 1/3 the length of the base, you would have to say 1/3. Why did you ask, did I put parentheses on this one and not brackets, and the other one I put brackets on? Doesn't matter, they're both grouping symbols, just sometimes I get sick of writing too many parentheses. Okay, I'm still going to take that 9.978 value. I'm going to go up to where I just got that. That one. Times 2. You should get 19.956 or 0.957, depending on what you want to write on that one. Rounding and truncating. And one more. Oh my goodness, can you feel it? Should you finish it? I'm taking that value times 1/3. 3.326. Squeal! Apparently that's what we do when we finish calculus notes. Not just for today, but all of the daily lessons. I squealed. Maybe you squeal too. Maybe you want an asymptotic high five from wherever you are. Woo. Great job. This is a really big day, just because you've put in a whole lot of work to get here, and I really appreciate you. Thanks for being awesome. Thanks for learning, and